we start off with the segmentation, so building its rules around that are used in order to constrain the targets that are going to be generated from the optimization process. And these business rules are really important to bring business logic and context to the target definition process. We believe in a glass box model, a segmentation and rules model that leads to optimized targets that the users, both those that are building the system and those that consume the information, the sales organization, should easily understand. I'm going to take you through these 3 steps. So segmentation, we think of segmentation as a price segmentation. So segmentation for the purposes of pricing that reflects customers' willingness to pay. And this differentiates itself from maybe other classifications or industry segmentation that you may have in your data. We certainly want to use that information, but that may only be one part of the model. So segmentation is built using 3 key groups of data. So product dimensions, customer dimensions, and transaction dimensions. And it's the combination of these dimensions that are brought together that are useful in building the price segmentation model. And we expect this data to come from your master data, so products, the product hierarchy, customer hierarchy, where those customers are. Some of these dimensions may be calculated, so profit or revenue classes for both products and customers. And then there are other things that we might like to look at. So the percentage of portfolio being purchased by the customer, or is this the first time that you've offered a particular product to the customer? These can make a difference in the segmentation model and in the targets that you want to recommend to your sales organization. So we take these dimensions and we build a model that we commonly describe as a tree, as opposed to a cube. The benefit of the tree model is that we will only use dimensions that are useful. We will have, at the end of the day, a manageable number of segments that can be understood, can be interpreted by the sales organization. And all segments in this model will have enough data that is given through the process that we use in the algorithm. And this is different to a cube model, sometimes called a micro-segmentation model, where there's a lot of interpretation required. You end up with tens of thousands of segments, and we do not see the applicability of this type of model in the business-to-business environment. So I have my segmentation tree. Once I have that tree, what happens next? So you can imagine with each of the nodes of the segmentation tree, I have a distribution of data. And this can be determined by an analysis of discount off list, by margin percent, or in some cases, margin per unit, where that makes sense. So that distribution of data is then contextual. It belongs with the segment. We've defined the grouping at which we are going to then make the recommendations. And we do that using a concept that we call power and risk. And this is actually a patented concept. Vendavo has had this, used this for a long time. A lot of our customers are using this. Pricing power reflects your unrealized ability to change or raise prices. And pricing risk reflects what's at stake. Essentially, if I set the wrong targets, and get it wrong. A combination of quantitative metrics that we can derive from the data and qualitative metrics that can be brought into the model. Competitive intensity, for example, is a good power metric. Capacity utilization on the market. And those qualitative metrics are often metrics that need to be taken from an unstructured data set and turned into structured data so they can be used and checked in the model. So this combination of power and risk is a trade-off model. It leads to a recommendation of the optimal target price. With that, then, we have a strategic map. And conceptually, what we are doing is looking at the trade-off between pricing power and pricing risk. So intuitively, I understand that where I have high pricing power, I have high ability to raise prices, and the risk is low. There is not as much at stake if I move my targets and get it wrong. Then this is segments of my business where I want to push pricing much harder. So in that type of segment, I will see a recommendation from the algorithm with a much higher percentile recommendation on that distribution. Conversely, if I have low power and high risk, I will see the algorithm be probably more conservative about the recommendations. This is where you may want to maintain your pricing rather than pushing hard. And it's this differentiation, first of all, at the segment level, understanding that willingness to pay is different by segment, and then the layer of power and risk that really drives optimal targets being delivered to the sales team from this model. So I've talked a lot about targets. Of course, with that comes the guidance for a floor and stretch value. And we want to govern, of course, the floors, the level of flexibility for the sales team. And we also want to encourage through the stretch, the sales team to push as far as they can within a realistic context of the segment. So that was a quick flow through of the theory. And now we'll take a look at the software. So we're going to follow the same approach. Segment, constrain, optimize. Build a segmentation model, set the business rules to constrain the targets that are going to be generated by the model, and I'll explain exactly what those look like, and then use the algorithm to set optimized targets to guide the sales organization. So what we're trying to achieve, and this is an example out of Vendavo CPQ, is the delivery of that target into the quoting solution of choice. And then the guidance, stretch, target, floor, through easy to understand indicators, green, yellow, red, or on a thermometer, as you see here, to help the sales organization negotiate with more confidence. This is the end game. And what we're going to take a look at is how the central pricing team, product management team, could be a sales operations team, but that central team can build and manage the model and then use the capabilities to deliver these target prices. Okay, so 3 steps to my demonstration. Of course, they follow those 3 steps. I'm going to start off by looking at a segmentation model that I have set up. So I'm a central owner of the model, delivering this potentially as a service to the business unit or product owners, working with them to build this model. And there's an interaction between the algorithms and my business understanding that allows me to make changes where I don't see the model fitting so well. And we'll take a look at that process. So I'm going to look at a model that already exists, check a couple of segments and see how the algorithms are providing guidance. I'll then, at one point of the segmentation model, there is a branch of the tree I want to adjust, and we'll take a look at how I can manage that process. So in Vendavo Deal Price Optimizer, I have a set of models that are currently in draft status. Of course, this gives me the opportunity to run and test different models. Certainly something that the value consulting team working together with our customers at the beginning of the project would use. And then, of course, over time, we're handing that process over to our customers. And this becomes a fully self-sufficient and management process of the model. So I have a segmentation model that I have created. Right now, I see there's 151 nodes in this tree. The distribution of data, and in this particular model, we are using margin percent as the model. I see that there are around about $750 million of revenue in here, 39,000 transactions, and then the different metrics that as we go through the model will give me an understanding of the performance at individual segment levels. So let me take an example segment here. So this is a segment that's in the electronics business. And that business unit structure here at the top of the model was something that I selected. I then asked the algorithm to run, and it was the algorithm that chose these different dimensions as the best dimensions in that order to explain willingness to pay. And then as we see down here with product volume, I have different values that are part of that dimension set and need to be separated in order to recognize that willingness to pay. So this is my segment level. I have a full overview of the product level transactions in this segment. So just a reminder, this is a segmentation model. These products could in fact also appear somewhere else in a different segment. So this is the performance of the transactions for these products within this segment and how they are performing relative to the margin target for this particular segment. So we're providing the analytics and data that is relevant to that segment as I'm running through my checks. So this is my segmentation model. You can then also check the optimization. And we see here the power and risk scores that were calculated using the metrics. So for power, we have skewness and standard deviation. For risk, I'm using margin percent, number of customers in the segment, and total revenue. And I can see over here that I have a segment that has high power, medium to low risk, and the percentile in this distribution that has been recommended by the algorithm sits here at the 66 percentile, and that translates into a margin percent. So the percentile is the position on the distribution. The dependent variable that we are analyzing is margin percent. So my target recommendation at the 66th percentile is coincidentally in this case around 67%. And that's important because we set those percentiles through the algorithm, but as your transactions update and are loaded into the system, so the distribution of data will shift and the target itself will also shift. So this was one example of a segment I have just by way of a different recommendation. So a segment here with low power or medium to low power, relatively high risk. So here we're just selecting, the algorithm selected the 57th percentile. For this particular set of products, the margins overall are much higher. So while it is more conservative for these products themselves, the margin actually is higher. And this is how the combination of segmentation and then the optimization power and risk process will work. So I have my business units set up. The algorithm has selected the next set the dimensions. And here in the Americas, I see that I have a split between channels. And that's actually something that I wanted to adjust. And so I will be able to go into the model, delete the subtree, and then have the algorithm rerun at this level. So delete the subtree. I can either rerun the algorithm or I'm able to use my business insight. So I want, for example, to manually insert product volume into the model at this level. And so this is the interaction between the algorithm and my business knowledge that is an important part of the process in building a fully transparent and dynamic model that reflects your business requirements. So, build the segmentation model, improve sales efficiency. We see our customers able, through more accurate target guidance on the basis of segmentation modeling, able to not only drive higher levels of margin, but also reduce quote response time because the targets that the sales team are using are more accurate. So the second step then, having built my segmentation model, I'm happy with that, is to overlay then the set of business rules in order to constrain the targets. And we're going to do this by thinking about different business scenarios that make sense. So two basic scenarios that we almost always use across the board with our customers. The first one is, of course, I have this distribution of data. I'm going to recommend a target price. For some sales teams, for some customers, that's a high jump to ask for in one go. So the first business rule is, on top of the recommendations, don't increase a customer's price by too much. So we can set a price change cap that limits the increase that is being shown to the sales team. This is a really important business rule to drive adoption in the sales team and not to overwhelm the sales organization, not to receive that feedback that maybe you get today that the targets being recommended in the system are unrealistic. So the idea here is, I would say, the model says this is my target based on that percentile, and then the equated margin percent. But for any customer down here, I only want to increase the price target by X, so let's say 5 or 10%, until they get within the range of the target, and then the target recommendation would kick in. On the reverse or flip side of that, we have customers that are actually, because it's a distribution of data, paying more today than the recommended target. And we, of course, don't want to lose that business. So the second rule is if the customer's business is higher than the target, then we would use the current, in this case, margin percent as the target and not the target selected by the algorithm. So business logic built into the process in order to drive adoption and recognizing sensible business processes. So these are also managed directly in the UI through a formula builder. So the target margin relative to the last margin, I want to set a price change cap. In this case, I've selected 15%. And so those different business rules can be set up actually at any level of the segmentation model. So I have the ability to set it at the highest level and then manage through exception at lower levels of the segmentation model where it makes sense. So, as I said, driving acceptance and adoption, really helping the sales team see targets that they feel comfortable using. Okay, my third and last step then is to set and run the optimize targets. And again, we use this concept of management by exception. So I can choose actually between the algorithm, setting a manual percentile, setting a manual percentage at any level of the segmentation model and have that inherit down through the model. So 3 steps for that process. So I have my optimization that is currently generated by the algorithm. And I can see here in this case, I have the percentile suggested by the algorithm. As I said, I can set a manual percentile or a manual margin. And my floor and stretch in this case are defined as a percentile offset from that target. What we often hear is that the floors should have a manual minimum margin. So in this particular case, I'm able to make those changes, again, at any level of the model. If I'd set that at a higher level, that would have been inherited down. Once I've set this up with my business rules, then the system will generate a set of guidance. So by segment, by product, customer combination, I have the target, the floor, and the stretch margin percent. And that equates to, because we have the current costs loaded, the target, floor, and stretch pricing. We get an API call from the quoting system, whichever that is. That includes the segment information. This is the data, including in the segment description, that would go back to the quoting system with that optimized target price. So an easy process, updated on a regular basis as the transaction data updates, really driving the effective execution of your business strategy. Okay, so that was Vendavo Deal Price Optimizer. And then just to conclude, I want to spend a couple of minutes talking about volume curve optimization. So this is part of the solution that has been developed for customers that in particular have this price volume trade-off in their negotiations. In the high-tech business, we see this a lot, where pricing is determined by a list price curve with different volume thresholds and different breakpoints in that model. So the volume impact of the negotiated price or margin needs to be extracted from that willingness to pay. And so we have two parts to reflecting willingness to pay. That is the volume part of the deal, and then that willingness to pay part. So the volume curve optimization of Vendavo looks at that relationship between price and volume and uses an algorithm to determine what that price volume curve should look like. So if you think to what we've just seen, what we are doing is taking the transaction data, so list price, final price, extracting the volume component by using this curve, and then separating out the willingness to pay part of the negotiated process. So volume curve then determines almost by policy, depending on the volume in the deal, that part of the discount, and then the segmentation model determines the willingness to pay part of the discount. So this separation takes place.